Hi kids, it's Mr. Josephs here. I'm going to go over the answers to the test 1 review with you right here. So, the first question says, is a conversion factor is what? A ratio of two unequal measurements, a ratio of two equivalent units, a ratio of two equivalent measurements, or a ratio of two equivalent numbers. Now, a conversion factor is equivalent to 1, okay? And that means we have to have a ratio that's the same on the top and the same on the bottom, okay? And so an example might be 3 feet for 1 yard. Well, this measurement, 3 feet, is equivalent to this measurement, 1 yard. And so that's a conversion factor, and so this is basically a ratio of two equivalent measurements. So the answer is C. Ratio of two equivalent numbers would just be like 2 over 2, and a ratio of two equivalent units would be something like milliliters over centimeters cubed, but that happens very rarely. A ratio of two unequal measurements, that just makes no sense. You can't have that happen. It needs to equal to 1. Now, which is the correct unit factor to convert between seconds and minutes? All right, so it doesn't tell us that it has to be seconds to minutes, it just has to be between seconds and minutes. So it must have seconds and minutes inside of it. And that eliminates those two choices, B and C. And which of these makes sense? What is an equivalent minute? What are equivalent measurements? Is 60 minutes equivalent to 1 second? Or is 60 seconds equivalent to 1 minute? And of course the answer is 60 seconds is equivalent to 1 minute. An adventure park decides to install a new zip line. You are tasked with obtaining enough cable for the new ride. How much cable should be obtained if the angle of the zip line to the horizontal is 23 degrees and the total horizontal distance traveled by the zip line is 200 meters? Draw a label and show all calculations. Okay, so we'll attach this zip line. Let's say it's attached to a cliff here. Okay, here's a cliff, and we're going to have a zip line. It's going to come down like this. It said the angle to the horizontal is 23 degrees. So this is going to be 23 degrees right here, right? And the horizontal distance traveled is this right here. So this is going to be 200 meters, right? And we want to know what the length, what the length of the cable should be. This is the cable up here, right? Okay, so that will be our x, what we're trying to find. So we know that 200 meters, because of our trig stuff from our reference tables, 200 meters over x is equal to the cosine of 23 degrees. And if we solve for x, we find that it's 200 meters over the cosine of 23 degrees. So let me get my calculator here. 200 divided by the cosine of 23 gives us 217 meters. Now I didn't pay attention to significant figures here. I mean, 200 would be one significant figure, but I'll put a dot there to say that it's 3, because if we don't, we'll just round to 200 again. And this has two significant figures in it, the angle does, so we'll say that for significant figures it's 220 meters. It makes sense that it's a little longer than the horizontal, because it's coming down to that angle. All right, Susie needs 2 new curtains for her windows. She measures the width of the windows in centimeters and found out that it was 75 centimeters. However, when she ordered them online, she found out that they were only sold in meters. Instead of remeasuring her windows, she merely completed a quick unit conversion problem. She came up with 2 unit conversion factors, one of which would be used in her calculation. What are the 2 unit conversion factors that could convert between? What are the 2 unit factors that could? I should say that. That's annoying. That could convert between centimeters and meters, and between meters and centimeters. So the 2 conversion factors are just reciprocals of each other. We know that 100 centimeters is in 1 meter, or we can also say that 1 meter is 100 centimeters. could also, from the reference tables, say 1 or 10 to the negative 2 meters is equivalent to 1 centimeter. And also 1 centimeter is equivalent to 10 to the minus 2 meters. Mount Everest is 8,848 meters above sea level. Use conversion factors to express this measurement in kilometers and show all your work, and remember to include all units. If we're going from meters to kilometers, we can set up the conversion factors, which would be 1 meter is the same as 10 to the negative third. Never mind. Let me do it this way. 10 to the third meters is the same as 1 kilometer. That's from the reference tables. Or 1 kilometer is 10 to the third meters. And we're going to do a conversion factor to convert this 8,848 meters. And we'll apply this 10 to the third meters on the bottom, 1 kilometer on the top. The meters cancel out. This is 8,848 divided by 1,000. You get 8.848 meters. And because the conversion factor has infinite number of significant figures, this is our answer. We do not need to round it down at all, or round it to less significant figures. So a penny has a diameter of 1.9 centimeters. Using unit conversion factors, express this measurement in millimeters. 1 centimeter is the same as 10 millimeters. Show all your work. Okay, so we're going to start with 1.9 centimeters over 1, and to make the conversion factor between the two, we take the number that's next to the centimeters and we put it next to the millimeters, and of course you can know exactly how many. It tells us, never mind, I was going to use the reference tables, but it tells us right here 1 centimeter is equal to 10 millimeters. The centimeters cancel out and we get 190 millimeters. Okay, and that's the correct number of significant figures right there. A teacher teaches 4 classes. Each class has an average of 22 students. Each class is given 5 assignments per week. The teacher takes approximately 45 seconds to grade a paper. How many hours per week is dedicated to grading? Use one conversion factor problem to find the solution. All right, so we need to figure out what goes first. And what we're going to do is we're going to say that this is 45 seconds per paper, because we're going to want to know how many hours per teacher per week we're going to have, okay? And what we'll have here is we got 5 papers per student, right, per week. Okay, and then we're going to multiply that by 23 students per class. Students per class, right? So the students cancel out. And there are 4 classes per teacher. Okay, and we're going to keep going here. We have 1 minute and 60 seconds. And then we go to hours from there. So we're going to bring it down here. We have 60 minutes per hour. Now we're going to cross off the like terms. So papers cross out, students cross out, classes cross out, okay? Seconds cross out, and minutes cross out. And we're left with how many hours per teacher per week. Okay, so we have 5.5 hours per teacher. That unit is still there, and the week is still there. And that's the final answer. And that's all we got.